Okay. So the next concept of digital logic design in fifth unit is the counters. How counters are being evaluated. Let us have a look here. The name itself indicates that counting. Counting in the sense, initially the value will be assigned to any one of the value. Let me say some kind of counters might be. So some kind of counters might be, for example, in our C programming language, I will be equal to 0, and then followed by in our loop. So for example, it could be the while loop or for loop. Let me say this is for loop. So you like to consider one condition will be framed here. That condition will be I less than or equal to some 10 or 20 or 30 or 100, whatever the value it may be. And you may be taken I plus plus might be taken, and you perform some number of operations here. So it could be initiated with 0, and condition will be checked, and after execution of these commands, it will be taken I plus plus. I plus plus in the sense, I must be increased by 1, that is plus 1. Okay, so I will be initially equal to 0, so it could be changed to 1. After some time, it could be changed to 2. In this way, in positive direction, the values are going to be increased. This scenario is called as counting. This scenario is called as counter operation. Okay. So how this counter operation, we have some examples with us, how these counter operations could be happen. Let us examine. So counters, what are the basic premises to be taken into consideration while counters will be taken into consideration? Look at this. There are two different types of probably wait for a while. This is not the actual thing. Yes, this one is the first part. Okay, counters. So already we have seen a register. A particular register will be there with us. Register will be sequence of flip-flops which are going to be attached in a sequence manner, and it could be performed some kind of operation, right? In the similar fashion, if a register will be prescribed with a sequence of states upon one particular operation. Okay, so sequence of states in the sense, so this is first state, this is the state number 1, followed by state number 2, followed by state number 3, and so on and so forth. Look at this. So this is 1, this is 0, this is 1 again, this is 0, this is 1 again, this is 0, and so on and so forth. So from this particular place to this place, completely called as one clock pulse. Okay. So within one clock pulse, two states might be there. One is up state and second one is down state. That is 1 or 0. Okay. Two states might be available here. So to perform these operations, the register will be acts or effects based on the states where exactly have with the clock pulse. Then such kind of application is called as a counter. So digitally speaking, that is a counter. Okay. Now this counter could be always activated based on counter could be always so executed based on so the clock pulses. Okay, there are certain number of clock pulses which are available. So clock pulses are very important for us. There might be having some maybe originated from external source, or maybe originated from so internal source. Okay, internal source in the sense, let me explain. So they might be fixed interval of time or random interval of time. Random interval of time in the sense, so 1, after this one, again 1, and followed by 0, 0, 0, 1, 1, 1, and so on and so forth. Fixed interval of time in the sense, so once 1 will be completed, immediately 0. 1 will be completed, immediately 0. This is fixed interval. Okay, this kind of thing will be called as fixed interval. This kind of thing will be called as random interval. Okay, So either of these two situations could be took place, then the register will be gets affected with some kind of output. Then such kind of registers are called as counters here. And here, so each and every time the counter will be effects based on the sequence of states where exactly it could be taken into consideration. If these sequence of states will be alternatively gets happen, alternative in the sense this is the way, okay, fixed time of interval. If alternatively gets happen, then such kind of registers, counters are called as binary counters. Okay, alternatively. So 1 followed by 0 and so on and so forth. You can consider, so if n will be equal to 2 in the sense, how many number of states will be there? 2 power 2, that will be equal to 4 states are there. If you write 4 states consecutively, so 0, 0, this is first state, 0, 1 from state 1 to state 2. This is the first case, and second case, first 0 will be as it is and second 0 will be changed from 0 to 1 here. State has been changed. Then followed by 1, 0. So this state will be so changed and this state also be changed. Now 1, 1. Okay, continuously the state has been changed in the first bit, and then second bit, so it would be change its state for every 2 intervals. For every 2 intervals it has been changed. If such cases will be there, such kind of modifications could be done. Those kind of counters will be called as binary counters. Okay, binary counters in the sense they will be effects on so binary digits. They will be effects on binary digits. Binary digits in the sense 0, 1. So directly, then such kind of counters will be called as binary counters. Whereas these binary counters will be of 2 types. Let us examine. Okay, if n number of bits will be available with your binary counter, if n will be equal to some 3, so you could able to count up to 0 to 7. Okay, if n will be equal to so 4, you could count up to 0 to so 15. Okay, if n will be equal to 5, number of bits will be equal to 5, so you can able to count from 0 to 31. So that is what the meaning here. So if n bit binary counter will be consists of n flip-flops, continuously n flip-flops will be there with you, and these could be count in the binary form through so 0 to 2 power n minus 1. So if you observe this particular point here, this particular point is 2 power 5, that is 32 minus 1. Okay, 0 to 2 power 5, that minus 1. So in this way you have to count here. So for applying counting, what exactly you required? N number of, what is the value of n here? N will be equal to 5, therefore 5 flip-flops are required. N will be equal to 4, therefore you required only 4 flip-flops. N will be equal to 3, you required only 3 flip-flops. Okay, they will be connected in series. Based on that, the counting operation will be takes place. Okay, counting operation will be takes place over there. So now let us consider there are 2 different types of categories of counters are available here. So first category is called as a ripple counter, otherwise asynchronous counter. What is the difference between so first category and second category? Okay, so a ripple counter or asynchronous counter, otherwise synchronous counter. This is second point will be so synchronous counter. What is the basic difference between these two? So already you need to remember one particular point here. The point is always counters will be activated or affected based on the clock pulses, only based on the clock pulses. Those clock pulses might be coming from external source in the sense a battery, a pulse generator will be connected to your counter, or internal source. Sometimes it could be taken from internal source also, and that might be in fixed interval form, otherwise random interval form. Okay, either of these. You need to remember this particular point here. It must be work on clock pulses. if a clock will be change its direction, let me say, so here this is 1, continue with 1 in the sense there is no change, there is no change, there is no change. Suddenly you will go ahead with 0, so then the clock will be triggered. So here it is 1, here it is 1, here it is 1. After 3 ones, so it will be turned to 0. Then again goes to 1, 1. So 1, 1. Then it will be goes to 0 here. So it is 0 here. Something like this. As and when change in the clock pulse, then the counter will be effects. If change could not be there, there is no effect in the specific counter here. So based on the clock pulses, you have to decide that whether it is a ripple counter or asynchronous counter, otherwise synchronous counter. Let me explain you. So look at this. So in ripple counter, what exactly it could be taken? So the flip-flop output will be transited and serves as a source for so triggering to other flip-flop. What does it mean? Let us take the example here. This is the first flip-flop which is being available. Whatever the flip-flop type it might be, whether it is SR, JK, or D, or T, we don't bother about this kind of thing here. So this is second flip-flop which is being taken into consideration. I wanted to implement only 2-bit counter, 2-bit counter in the sense 0 to up to 3. So it could be count 0 to 3, for example. So it does have some kind of inputs. For example, this is JK, consider JK. So J and K inputs might be there here. J and K inputs might be there here. You may be having some kind of another input here. That input is a clock here, CLK. Clock here. Okay. This clock will be for the first flip-flop. Clock will be connected from outside source. Okay. Whereas, so the clock will be connected for this particular. Let us consider this first flip-flop, and this is second flip-flop. It is also JK only. It is also JK only. This is the clock here. So this clock will be connected from the output of first first flip-flop. Okay. So if you are supposed to develop something like this, let us consider this is one kind of a counter. This is one kind of counter. Let us consider JK will be there, and there is a clock pulse, and here also JK will be there, and there is another clock pulse. So if all inputs, all what you call flip-flops will be connected through so common external clock pulse here in the sense this is called as synchronous. This is called as synchronous. This is the clock pulse. So from this particular clock pulse will be equal to 0. It will be also have 0. It is also have 0. Clock pulse will be equal to, see it is 1. So it could be taken 1 and it also be taken 1 here, because a common clock pulse will be connected to all flip-flops, whatever the number of flip-flops you have with you in your counter. Then it is called as synchronized. Whereas, so in second, let us consider third bit also. Let us consider it is also JK. Whatever the inputs of JK, it doesn't matter for us. We are talking about only clock. Okay. So here clock will be there and some output will be there here. So here output of second, so output will be connected to clock of third input. This is the first and this is the second and this is third. Third flip-flop will be works based on the output of second flip-flop. Second flip-flop will be works based on the output of so first flip-flop. First flip-flop will be works based on the external clock pulse. Understand? So first flip-flop will be works on based on external or external world clock pulse here. If this could be equal to 1, yes, it could be perform some operation. It could be equal to 0. So yes, first flip-flop will be done some kind of operation. And if external will be taken, then here whatever the output of this particular so first flip-flop, based on this first flip-flop output, so second flip-flop is being produce some kind of output. If it is 0, normally 0 will be there. There is no power. There is nothing will be there. If output of first flip-flop will be equal to 0, So second flip-flop cannot be do anything. If second flip-flop cannot do anything in the sense, obviously here also 0 will be there. Third flip-flop also cannot produce any kind of output. Okay, so that is what you need to understand. So clock pulses of inner flip-flops will be connected from its previous outputs. So if clocks will be connected in such a fashion, they will be called as asynchronous. So otherwise ripple. Otherwise these are called as ripple. Okay. So whatever the statement I have given, it is purely technical statement here. The technical statement will be so illustrated by taking this particular example, something like this. Okay, you need to understand this particular point here. Common clock pulse cannot be available in ripple counter or asynchronous counter. Common clock pulse cannot be available. Based on the activity of first flip-flop, second will be acts. Based on the activity of first and second flip-flops, third will be acted. Or third will be responded. If such kind of response will be there in the sequence of flip-flops, such kind of things will be called as either asynchronous flip-flops or it is, asynchronous counter or ripple counter. Whereas, let me erase everything here right now because some more data is there. So clock input of some of all flip-flops are triggered not by, you need to understand, not by common pulses, common clock pulses, okay? But rather, what exactly it could be done, so the transition will be occurs based on the other flip-flops outputs. Just now I have explained to you. First flip-flop will be, flip-flop number 1 will be, so generated some kind of output. Based on the output, second flip-flop will be worked. That will be transited. Based on the second flip-flop's output, third flip-flop will be transited. So hence what we have to consider, we don't have any common input, common clock input to all flip-flops which are being connected in the counter. Okay, such kind of things are called as ripple counters or asynchronous counters. Okay, now so synchronous counters. Unlike in asynchronous, synchronous counter, I have given just before one example to you in this particular scenario. There are so 3-bit so counter will be there. All these 3 bits are supposed to be, let us consider, so this is first flip-flop and this is second flip-flop and that is third flip-flop. So common clock pulse is being used for providing some counting operation here. If this is the common clock pulse, so if this clock will be having 0, everything will be taken 0. If clock will be equal to 1, everything will be taken 1. So that is why common clock pulse, common external clock pulse will be connected to all flip-flops. Then that is called as synchronous counter. Okay. So normally based on the activity of external counter or internal ripple counter or synchronous counter, whatever the counter type it might be, we do have 2 different types of counters. One is up counter. Up counter in the sense it could be get started at 0 and go on up to infinity based on your number. Okay, whatever the specific number you have to set for that particular counter, up to that particular point, it will be go ahead. Instead of infinity, you may be write n. Okay, if n will be equal to 20, up to 20 it will be counted. N will be equal to, so 1 lakh, up to 1 lakh it will be counted. Where exactly you have to use this up counter? There are many real-time applications for up counter. So for example, EVMs, electronic voting machines. If any person will be vote for one particular party, previously all parties might have 0. I have posted my, or I have click my vote for X party. X party will be increased by 1, that is 0 to 1, and remaining everything will be 0. And second person will be vote for, click on Y party, previously it is 0, now it will be increased by 1, that is 1. So X party 1, Y party 1, and Z party 0, and A party will be 0, something like that. In this way, you could increase, up counter will be used. In another scenario, so many people are withdrawing money. Many people are withdrawing money from ATM. ATM will be always maintain a counter for each and every day. So day after when time will be converted from yesterday's date to today's date, when it will be changed from 11:59 to 12 a.m. in the midnight. Obviously, the counter will be set to 0. Okay, if one person will be withdraw, so the count will be increased by 1. Yes, one transaction was happened. Second person will be withdraw one more time. Yes, second transaction will be happen. So in this way it will be increased with by one by one, based on the transactions which were happened through that particular ATM machine. Okay, this is one more example for up counter. Okay, likewise, you do have many, as much as many number of examples are there for up counters. And down counts. One more thing is a down counter. Down counter will be starts with so-called value which we have to specify here, n. So then n minus 1, n minus 2, n minus 3, and so on and so forth to 0. As and when 0 will becomes, obviously the down counter cannot be reoperate below 0 here. Normally example, real-time example for this particular down counter is as and when rocket launching will be there, those people will be down counted. 9, 8, 6, 7, like that they will be down count. As and when the counter will be reaches to, okay, counter will be reaches to 0, then operation will be triggered. Otherwise, if you go ahead with any number of any kind of corporate shops, let me say Reliance or something like that. So all items might be having with a stock something like some paste will be, so pastes will be having some 200 pastes are there. 2 persons have been purchased paste, 2 pastes, then it will be reduced to 198. So it is also down counter. Okay, like this you have as many number of examples, real-time examples for up counter and down counters here. Okay, up counter will be always starts with 0, down counter will be always starts with n here. Okay, that is what you need to remember here. However, what is the present state of the counter here? In the sense, the present state will be what exactly the state of that particular counter which is maintained. For example, so up counter initially it has been started 0. After 2 operations, it will be set to 2. The present state will be 2. Okay, so that is what the down counter also it would be starts with n. So 2 operations will be done, so that n minus 1, n minus 2, whatever the n value minus 2, that is the present state of the counter here. Then how many number of okay, so how many number of operations could be happened here? Those operations will be took place by this particular up counter or down counter here. So here we have been developed one circuit for asynchronous. You try to understand. I could not give you this particular explanation today because the preparation of this one is not completely done here. Okay, otherwise you can see I have prepared everything, but similar day you could not understand properly here. However, you could see this this one is 1 and this one is 2 and this one is 3. So Q0, Q1, Q2. So you could see external clock pulse will be given as input to first number 1 flip flop, and whatever the output you have with you from flip flop number 1, it has been given to input of a second flip flop, and whatever the output of second flip flop will be connected to third flip flop. So only one flip flop has been connected with external, and remaining everything will be connected based on the previous level of flip flops here. So that is what you need to remember, so that it is called as a ripple counter. Okay, so all flip flops cannot be taken the same clock pulse from the external source. They will be connected from the previous stage flip flops only. So that is why it is called as a ripple counter. Let me explain this particular ripple counter by tomorrow, because today many people have not attended. Only 5 people are there, and all those 5 people, during these 5 people, and what do you call